Okay, let's go and tackle this nice, interesting math problem. So let me go ahead and set this up for you. So here we have a boat, and this boat is going due east at 15 knots. Okay, so just as a little aside, if you're on the ocean, you're talking about boats, we don't use miles per hour. We use knots as a unit measure of speed. But anyways, this boat is going due east at 15 knots, and we have a cross current. So this could be like a river or some sort of lake or ocean, but this cross current is due south and it's traveling, or the current is at 2 knots. So obviously the current is going to be pushing this boat, if you kind of think about it. So this boat isn't going to remain due east. It's going to get kind of pushed off in this direction. So we want to know is the true boat's speed and heading. Okay, where is it actually heading? I mean, obviously the captain of the boat is pointing the vessel due east, but it's because of the current, it's actually getting pushed in this direction. So this is going to be a nice, interesting problem to figure out. Now you're going to need a calculator and some pretty decent understanding of some mathematical principles, but primarily we're going to be talking about vectors. And if you never heard of vectors, well, you want to stick around for a couple minutes and don't let this problem intimidate you. Now, if you can figure out the answer, go ahead and put that into the comment section. Just as a side, I kind of find this problem, there's kind of a special place in my heart for this type of problem, as in a former life, I actually was a U.S. Navy surface warfare officer. I actually was in the did two tours in the military. I was in the Marine Corps as an enlisted person, and later on, I was a Navy officer. I drove amphibious ships, and I was a navigator. So I actually used to do this stuff for a living. So yes, mathematics has a lot of applications. But anyways, we're going to get to the correct answer here in just one moment, and then we're going to talk about vectors and how to find the solution to this problem. But before we get going, let me quickly introduce myself. My name is John. I'm the founder of TC Math Academy. I'm also a middle and high school math teacher. I've been teaching math for decades. It is my true passion. And I'm telling you right now, all of you can be successful in mathematics, but what you need is encouragement and great math instruction. And I'm speaking to those of you that especially struggle in math. If you failed a couple math courses, don't let that like defeat you. Okay, if you're struggling right now, you can do much better. Okay, so it's a lot of this is about your attitude, but the most important part is having access to excellent instruction that you understand. So if you need help in your current math course, or maybe some sort of special test you are preparing for, something with math on it, I'm talking about things like the GED, SAT, ACT, ASVAB, maybe a teacher certification exam, or if you're homeschooling mathematics, check out my math help program. I'm going to leave a link to it in the description of this video. I literally have over 100 plus different math courses that span these categories and much, much more. I'm also going to leave links to my math notes, as everyone needs math notes. If you're not taking your own notes right now, you're doing yourself a big disservice. If you want to be successful in math, you have to learn how to be a great note taker. But in the meantime, you can use my notes. And if this video helps you out, don't forget to like and subscribe, as that definitely helps me out. Okay, so let's go ahead and take a look at the answer here. So again, we have this boat. It's going due east. We got the current pushing against the boat, so it's going to end up going somewhere in this direction. So let's take a look at the boat's true speed and heading. Okay, so here you go. The boat is actually going at 15.13 knots, so a little bit faster than what the captain has dialed in, right? So we're going 15 knots this way, due east. Now, I'll talk a little bit more about the directions here, but the actual direction of the boat is 97.59 degrees. So it's going 97.59 degrees at 15.13 knots. That's the effect this 2 knots of current is having on the boat. So if you're a little bit confused, just kind of stand back and think about the big picture here for a second. But before I even talk about this, if you happen to have gotten this correct, that's very impressive, certainly impressive enough for a nice happy face, an A plus, a 100%, and a multiple stars to celebrate your success using vectors to figure out basic math problems. So again, I keep coming back to this topic of vectors. And vectors is critically important, not only in mathematics, but engineering, science, and that's what we're going to need to understand in order to solve this problem. But let's just kind of, again, kind of think about the big picture here. So we have a boat, right? So even like an airplane, well here, let's just use the boat. The boat's going this way, but we have some current pushing it this way. So the boat's not going to, continue to be on this path. It's going to get pushed kind of off in this direction, okay? And this current is actually speeding up the boat just a bit because right here, that boat was at 15 knots and the actual speed of the boat is 15.13 knots. So you get a little bit increase in speed and obviously we have a new direction. So let's go ahead and get into this right now. Okay, so again, we have to know something about vectors. And if you never heard of vectors before, well, this is going to be a quick introduction to them. And kind of the main idea behind a vector is something that represents both speed and direction. And what we're going to be using is arrows. Okay, so you can kind of see we have an arrow right here that is representing the direction of the boat, and we have another arrow right here that represents the direction and speed of the current. This is also representing the speed of the boat and the direction, and that's what vectors are. Basically, you can think of them as arrows where the length of the arrow is the speed and the direction the arrow is pointing in is an important part of solving problems. So in vector problems, you can have an arrow pointing this way, you can have an arrow pointing like this, you can have an arrow pointing like so, or like this way or this way. And again, a vector is something that represents both speed and direction, okay, more magnitude and direction. So the length of the arrow is the speed or magnitude or velocity, and then the actual direction of the arrow is the actual direction, okay. So we can measure that in terms of degrees, and let's go ahead and get into this right now. Okay, so in order to really kind of understand vectors for this particular problem, let's just make sure we have a basic sense of a compass heading. So we're talking about due east and due south. So on a compass, if you wanted to go due north, right, we're talking true degrees, not a magnetic compass, because in the magnetic compass world, if you're going north, and you're using a magnetic compass, you're actually kind of going off in another direction. That's a whole other topic. But this is if you have a gyro compass, we're talking about true degrees here. So if you're going 0 degrees, you're going due north. Okay. Of course, this way you'd be going northeast, but let's just kind of get the basic sense here. So we're going to start at 0 degrees, and then we're going to kind of go this way. All right. So if you're going east, you're going to be going 090 degrees or 990 degrees. That's due east. So our boat is traveling due east. And south, due south is 180 degrees. So we're just, thinking about a circle. Here's 0. This is 90. This is 180. Here is 270. Same thing here. So due south is 180 degrees, and then due west is 270 degrees. And of course, you can have any number of directions on this basic compass heading here. So anyways, we're talking about true degrees. So if you were confused about that, well, the boat is going due east, so it's going 90 degrees, and the current is going due south, so it's actually pointing 180 degrees. So what we have to do now is put this information on this plot. So let's go ahead and do this now. Okay, so again, a vector is an arrow. Okay, I'm kind of speaking in loose language here. It's not a formal, formal instruction on vectors. You really kind of have to go through this, kind of build this up. But I think, hopefully this is an easy enough introduction to these concepts that you understand. But again, a vector is an arrow, okay, where it's going to be representing speed and direction. So let's go ahead and take a look at our boat. So our boat here, okay, is going 15 knots due east. So let me kind of give this some kind of room here so we can see everything. So notice this arrow is 15, okay? Now in comparison to the current is 2 knots, so it's going to be a smaller arrow. The length of the arrow is what is telling us the amount of speed. So if I was talking about a 30 knot, okay, speed, I would double the length of this arrow. So it might be something like that, right? Okay, so the length is what determines the speed or velocity, or what we call magnitude. We're discussing vectors more formally, but the boat is going due east. Okay, so when we write this arrow, we're going to have it pointing in this due east direction. So I'm kind of putting it off to the side here just to kind of speak about this. But now we have the current pointing due south. Okay, so it's going due south. It's going towards 180 degrees. So here is a 2-knot arrow pointing due south, and here is a 15-knot arrow pointing due east. So what we have to do is plot these onto our lovely little graph here, and we're going to talk about how to get the answer. I'm going to do that right now. Okay, so moving on. Now, this might be a little bit hard to see, but this right here is our boat arrow. Okay, so we're starting from the origin here, and this is 15 knots. Okay, so we're going to do this again in blue. So right here is our boat. So we're going to start with our boat. Okay, we're going to put its what we call the tail, and this is the head of the vector. Okay, so this is the tail, and this is the tip or the head, however you want to think of it. But we're going to start right here in the center. And so we're going to put that arrow from the tail of that boat vector. We're going to put it right here. I'm going to draw out due east 15. So if this was like an XY plot, you just kind of go out here, 15, and this is our boat vector. So what we're doing right now is something called vector addition. So the way it works is the following. You put one vector, like for example, our boat vector, and then we're going to put our current vector this way, okay? So the way it works is this. The tail of the second vector, okay, the end of it, is going to start at the tip of the first vector, okay? And of course, you have to consider the direction of these vectors. So you can have, let's say, a vector like this and a vector going this way. Again, we have to be mindful of the direction, but being that the current is going due south, it's going to be pointing just like this. Okay, so hopefully I'm making sense to you, but here is our boat vector. Now here is our current vector, and we're going to put that to start the tail of that vector at the tip or the start of that first vector. Okay, so the way you get the answer to the true heading and speed of this boat is through something called vector addition. All right, so once we have this set up this way, the tail of the first, okay, going to the tip of the second, this one right here is our answer. Okay, this is the actual true, the length of this arrow right here is the actual true speed of the boat. And this direction is the actual true direction that this boat is traveling in, obviously with the current acting upon the boat. So what we have to do is figure out this lovely math problem. And of course, we'll be using some interesting things like the Pythagorean theorem and some basic trigonometry. So if you've never seen this stuff before, don't let this intimidate you too much. Just kind of get a feel for what's going on. Anyone could do this stuff. You just kind of have to build yourself up to it. But let's go ahead and now kind of see this a little bit more clearly. So the true boat speed and heading is represented by what we call the resultant vector. So again, we're going to put the boat vector here, and then we're going to put the current vector. We're going to start it at the beginning or at the end or the tip of that boat vector, just like this. And then from the tail of the first to the tip of the second, this is what we call the resultant vector. This represents, again, the actual answer, right? The true boat speed and heading with this current acted upon the boat. All right, so really this kind of distills down to a nice math problem. And because this is 90 degrees this way and this is 180 degrees this way, this is a nice right triangle right there. And let's go ahead and take a look at what we need to do to solve this. Okay, so the first things first, here is kind of basically what we need to focus in on. So we have a triangle that's 15 by 2, right? This is the boat direction and speed, right? 15, and then this would be the current direction and speed. But now we're just kind of focusing in on this triangle. So the first thing we want to do is get the length of this hypotenuse. The length of this from here to here is going to represent what? This is going to represent the speed, the true speed of the boat. So how can I find the length of this right triangle? This is the hypotenuse. Well, hopefully you recognize this guy right here. This is the Pythagorean theorem. Okay, a squared plus b squared is equal to c squared. And right here, this length is actually c, or the hypotenuse. Okay, so all we need to do is square this side and this side. So let's go and do that now. So that's going to be 15 squared plus 2 squared is 225 plus 4 squared is equal to x squared. That's what we're solving for. If you've never seen the Pythagorean theorem, or if you need practice with any of this stuff, probably want to check out like my pre-algebra course. I kind of go over this, my Algebra 1 course. But basic trigonometry as well, which we're going to need, you can find that in my geometry course, in my math help program, and I certainly teach all of this thoroughly in my pre-calculus course. But anyways, we have 225 plus 4 is x squared is equal to 229. So let's solve for x. We simply have to take the square root of both sides of the equation. We get x is equal to approximately 15.13. Okay, so that is the length of the hypotenuse, and that represents the actual true speed of the boat with this 2 knots of current on it. So, kind of interesting to think about it, right? Your boat's going like this, you're having a little bit of cross current. It's actually going to speed you up just a tad. If you were thinking, is it going to slow me down or is it going to have any effect? Well, it's going to speed you up just a little bit. Okay, so we have the speed, and now what we need to do is work on the direction. All right, so back to our triangle. And now that we have the hypotenuse here, we have a completed right triangle with all the sides. And what we have to do now is find this angle right here. Okay, this is the angle we need to solve for. And here, when you only have the sides of a right triangle, you need to use basic right triangle trigonometry. So we're trying to find this angle, and hopefully if you understand basic right angle trigonometry, you know this saying. Okay, let me go ahead and tell you this saying real quick, just in case you haven't seen this. This is SOHCAHTOA. It's a crazy saying, but this is the sine. The sine of an angle is equal to the opposite over the hypotenuse. The cosine of an angle is equal to the adjacent over the hypotenuse. And the tangent of an angle, let me put this right here, is equal to the opposite over the adjacent. So just some real basic stuff on triangles. Here are triangles this way. We're looking for this angle right here, okay? So the angle, the longest angle in a right triangle is always the hypotenuse, okay? Now, the side that's helping to form that angle is what we call the adjacent side, and then the side opposite of that angle is, of course, the opposite side. So when I look at what's going on here, I'm trying to solve for this angle. What pieces of information do I have? Well, now I have the hypotenuse, but let's just take this out for a second. We only have these two pieces of information. As a matter of fact, you could use any of these, what we call trigonometric ratios, but I'm going to use the tangent because I have the opposite right here. Okay, I have the opposite side, and I also have the adjacent side. Now, of course, I do have the hypotenuse, which is that, I think that was that 15.13, if that was the correct answer. But let's see, yeah, 15.13. So if you wanted to, you could use a sine or cosine, but it's actually, because this is kind of rounded off, 15.13, you're better off using these lengths because these are not rounded. So what we need to do now is find this angle using the tangent. All right, so the tangent of this angle, again, is the opposite over the adjacent. The opposite side is 2, the adjacent side is 15, and 2 divided by 15 is 0.13 repeating, so 0.1 and a bunch of 3s that repeat. Okay, so what do we need to do now? Well, let's go ahead and break out our calculators, and we need to use this function on our calculator. This is called the arctangent, okay? And basically, on your calculator, generally speaking, you have to use the second function on your calculator. You hit that tangent button and that second button, and you'll get this arctangent. And when what this is basically going to tell us is what angle has a tangent of 1, 3, 3, 3, 3, 3. Okay, and you could just continue on. The more threes you put in here, the better off, the more accurate your answer is going to be. One point of caution, you need to make sure that your calculator is in degree mode. There's different modes on your calculator. You can work in degrees or radians when we're talking about angles. The default setting on your calculator will be degrees, but oftentimes students that are doing like trigonometry, they're going back and forth between radians and degrees, and sometimes they forget to go back from radians back into degrees. So make sure your calculator is on DEG. But when you put up this arctangent right here, or this tangent -1, this right here is basically it's saying, hey, what angle in degrees has a tangent of 0.1333? And when we hit the enter button, we get 7.59 degrees. Okay, so this is not the true heading, the true direction. We're going to have to use this information to give us a better answer. So let's go ahead and take a look at the final situation right now. Okay, so we just figured out, or previously to this angle, we figured out that the speed is 15.13, so that's this actual speed. But the heading, remember this boat was going 090 degrees or 90 degrees due east, and it's picked up, or it's kind of being offset, pushed down, pushed more south, 7.59 degrees. So what is its actual heading? Well, it's going to be 90 degrees plus that 7.59 degrees, and that's going to be 97.59 degrees. So this is the actual direction of the boat. Okay, so now that you have basic navigation skills, you can definitely go get a job for one of the big super tankers or carriers out on the oceans. As someone who's actually drove piloted big vessels and navigated them, it's you think about all the math that's out there, and this is just not with nautical stuff. You look up in the sky, you see all those airplanes, they're doing this constant math. Math is everywhere, and basically vectors is a huge, important part of mathematics. And even if you don't understand all the stuff that kind of, what's going on in this particular solution, hopefully you've gained some sort of an appreciation for vectors, okay? And if you have not yet studied vectors, you'll definitely study them. Probably, most of you will probably study vectors in probably pre-calculus or some sort of physics class, maybe, some basic introduction to them in geometry. But again, this stuff is not that difficult. You just have to work up to it, okay? You got to figure out, how to work with degrees, Pythagorean theorem, basic right angle trigonometry, etc., etc. Okay, so if this video was interesting to even some small degree, don't forget to like and subscribe. And with that being said, I definitely wish you all the best in your mathematics adventures. Thank you for your time and have a great day.